So we're going to talk about Go on a Trail, which is a citizen science project that we worked on this last summer. So NASA Globe Observer, which is an app you can all download right now if you want. Just look up NASA Globe Observer in the App Store. And the National Park Service's Lewis and Clark National Historic Trail teamed up for Go on a Trail campaign, where volunteers did data collection from June 1st to September 2nd, all along the Lewis and Clark National Historic Trail. And we did that to assist scientists studying environmental change. So they used the app to map land cover. And we also have people mapping elsewhere. We're going to focus on what happened on the trail. So we're going to kind of share some of the things we learned from this campaign, because we're hoping to do something similar next year, and then show you kind of a snippet of the data that we got. We just got it back a little over a month ago, so it doesn't look really pretty yet. We've got to clean it up, but we'll show you some land cover maps that we have. So if you want to follow along, this is an Esri story map. There is a QR code, and then also the tiny URL, which is tiny.cc NACIS_GOT for Go on a Trail, or Game of Thrones. Sometimes people get them confused. So if you do not know who Lewis and Clark are, I don't know if people are not from the United States, you might not have learned it in like 4th grade history, just to get everybody on board. So early 19th century, starting in 1908, Meriwether Lewis and William Clark, along with a whole team of people, they even had a dog named Seaman, and Sacagawea, if you've heard of her. They've had lots of people helping them on this expedition called the Corps of Discovery. So they started in the eastern United States, and were some of the first people to really go on a scientific expedition to map the rest of the United States. It wasn't quite all the United States yet, all the way to the West Coast. So they were focusing on mapping this kind of area between the Mississippi River to the Rockies, and the Rockies out here to the Pacific Coast. Wasn't really on maps yet. You can see kind of that big blank spot in that area. So that's what they were focused on doing. So they were charged with their mission to go explore the Missouri River, and then find the Pacific Ocean going through the Midwest and Western United States. And if you don't know a lot about Lewis and Clark, we can either talk about it at the banquet, or there is a really great Google Voyager story from PBS all about their expedition. So this link is live, and you can just go Google Voyager and PBS and Lewis and Clark. So the Lewis and Clark National Historic Trail was established. That follows along that historic route. So that is an official trail. You might have seen some of these trail markers, especially if you spend some time in the Pacific Northwest. They're kind of all over the place. So it is 3,700 miles right now, and they just announced in April this year that they're extending another 1,200 miles, starting in Pennsylvania and connecting into the Missouri River there. And there is a map of it in all the visitor centers. So there are many different visitor centers. There's Native American museums and visitor centers that are connected to the trail. So there's a big partnership of people and entities connected to the trail. It's also part of the National Trails Act and system, and that includes trails like the Appalachian Trail along these historic trails as well. So one of the reasons why we partnered with the Lewis and Clark National Historic Trail is not only that they expanded the trail to map that new section of trail that incorporates where Lewis and Clark kind of started in preparation and then actual initiation of the expedition, but also because it was the 50th anniversary of the National Trail System last year. So they wanted to kind of commemorate that event and partner with NASA to do land cover mapping. So Go on the Trail was the name of the campaign, and this is one of the social media posts that we had. So the goal of this was really to take the spirit from the Lewis and Clark expedition, their scientific journaling that they did and the mapping they did, and kind of bring that to the modern mobile app age, so everybody could act like Lewis and Clark and go along Lewis and Clark Trail and use their cell phone instead of like a pen and paper to map out the trail and collect data for us. There's some of our really beautiful maps that were made by Heather Mortimer, who is awesome, does great graphics. So the Globe Observer app was the mobile app that we used, and you can download it. So that in there is the land cover protocol, where people take a panorama photo and then identify land cover with their photos. And so then we can derive that to MOOC classifications and land cover classifications and kind of get a point within a pixel to do land cover. So again, if you want to know more about that, we can talk at the banquet. So here are the results that we have. So we had over 1,144 land cover observations, reached over 2.2 million people on social media for some social media posts. So there's the trail. I can zoom in a little bit. And then all of our observations there, you can see we kind of have some blank spots, but those are places there's not a ton of people. And then one of the lessons we learned, and I'll let you talk about this, Peter, was from our observation stations.
So one of the challenges that any cartographer should be wrestling with is what is the accuracy of these devices that people are wandering around with? And so as a scientist looking at putting together a good map, this is one of the foundational questions that we had kind of coming from NASA is how accurate are these? And so we sent around to the 150 visitor centers these calibration observation station stickers with the idea that people would put them out and we could get repeat observations in that location and then compare people's GPS results at that spot to get a better understanding of the accuracy as we move from urban areas out across to places that are a lot less urban, and we have a lot less cell signals, and therefore the accuracy of people's observations might be really bad. So our lesson learned was that many people had no idea how to use this. The whole idea of calibrating data is a foreign concept to a lot of people. And so I think it really goes into how trusting many people are of their devices, and therefore the quality of the map really makes a big difference. So unfortunately, we weren't able to get a lot of really good information from that calibration piece, which I think is a foundational part of using the mobile devices for any sort of mapping activity. And so really what we were trying to get at is this Modus Data. So Modus is one of the sensors that NASA has had up in space since the year 2000. And we've been going through, and people have used those space pictures or measurements to actually map out what they're seeing on the ground. And so in this case, it can kind of get broken down into deciduous forests on the East Coast for the most part, and conifer forests over here in the Pacific Northwest, and then a whole bunch of grassland in the middle of the country. Sometimes that's grassland that is being cultivated by people. Sometimes it is now just kind of the natural prairie land out there. And then obviously we have this river system that Lewis and Clark followed going across the whole way. But because of the resolution of the satellite, you can see that it really gets lost in a lot of the locations except for where the water's really wide and big. And so we have this map out there that actually shows us where NASA predicts what you'll find in that location. But I've always had that question and kind of nagging suspicion of like, are they right? Did they really get it right in this location? Has things changed since that person made the map in 2017? And so what we've been working with is the GLOBE program. NASA and NOAA, the State Department, the National Science Foundation in 1995 helped to create kind of the first global science effort using the internet as a way of connecting people around the world. And so the second protocol that they came up with was this land cover mapping activity. And so at the time, they would send people a satellite image, because that's how you got things at the time, through the mail. And people would go out and they would try to map out the land cover of what's there. And so with the app, we've basically taken that same process but automated it. And so you can see, I mean, these were some of the things that people mapped out and labeled out there. So trees, grass, urban areas, but about 80% of the photos that people submitted didn't have any labels with it. So we have pictures of what's on the ground, but we don't have a way of easily making a map. And so that's one of those big lessons that we sort of learned, is that people like to take photos, but they really hate documenting. And I think that's a common thing that all of us kind of wrestle with, is how to document our process and what we're actually measuring. So as we were going out, we wanted to kind of focus on an area that is close to where we're actually at. And so we're going to give a little bit more of an example here of what we were able to map out here.
So we're going to focus on an area not too far from here where the confluence of the Pacific Ocean Columbia river comes together just south of here by Portland. And so this will give you kind of our example of the actual land cover map that people produced this summer. So this was a good spot for the Lewis and Clark expedition. They stopped here and overwintered here in 1805 to 1806. And they have some nice journal entries. The mosquitoes are a big problem there. They also describe that there was hills, ravines, bogs with cranberries in this area. So we're going to talk about the Fort Clatsop area. If you've ever been there, Cape Disappointment, this kind of whole region, which is where they spent the winter. So there's Fort Clatsop there. And so we had quite a few observations from this area this summer, and here's some of the photos that were submitted: sandy areas, loosely spaced trees, tall grasses, and you can see a lot of them are other, so those are people who didn't label things, and we're working on that. We're gonna put photos up online and have people kind of do post classifications, so that's a whole nother topic for a different day. We can talk about that later if you want. And so now we're going to kind of compare what people actually posted from this summer when they did the Go on the Trail challenge to what Modus actually says the land cover is in that area.
So this is where I spend a lot of my time, is both making land cover maps like this, but then trying to figure out how accurate they are and what are the features that we might be missing. And I think one of the things that really pops out and that's really important is again the width of that river. And whether that river's actually wide enough in certain locations to get picked up by the satellite or the pixel to be labeled as a river. And this all goes back to estimating how much water's in a landscape or how much an urban area is in a landscape. And this is one of the big reasons why we make maps, is to try to come up with area estimates. And so that is definitely one of the big limitations that we see when we're looking at a global or a regional map that is of this 450 meter pixel scale. But we do see a lot of the features that humans will actually pick up when they're out there. And so as we zoom in and actually look, one of the things that we see is that, again, people didn't label a lot, so we can't do anything with that. But importantly, what we can do is when we do have labels, we can start making our own land cover maps that allow us to compare this map to, say, what people actually say is in that location. And it's a really bad sort of map because we're missing a lot of data. It violates almost every rule that somebody who makes a map learns about. Having a good sample, having a good representation in each one of your classes. And so right now, if you don't have a good sample design to deal with people out on the landscape, you end up with a map like this.
So all the gray area is non-classified areas. So hopefully we'll do some post-processing and get people to classify the photos later. But this is just the raw data from this summer that was pulled just a couple weeks ago. So. But you can still tell the blue is open water, that's the river, that's the Columbia River. So we do see some known points, even though this is just all the volunteer data. We do see some points popping up in known areas.
Yeah. And I think importantly, as somebody who makes maps, again, going through and actually looking at the accuracy of this, where are we having confusion between what people are seeing on the ground versus what NASA is mapping from space? We see that there is a lot of, people can identify urban areas pretty well, but as soon as they leave those urban areas, there's a lot of confusion between the grasslands that they're seeing versus what NASA has mapped out as actually trees or deciduous trees from space. And so if we just ignore all of those blank things that are out there and focus on what people actually labeled, we do a slightly better job, but there's still a lot of confusion that is both a resolution part of what people can see on the ground versus what we're getting from that view in space.
So they might be correct on the ground, but it's just the Modus resolution kind of washes away what they're seeing at their particular point. So.
Yeah, and that spatial scale difference between that human scale and the satellite scale is, I think, a fundamental misunderstanding that the public has about about how to use a map or the utility of some of the estimates that a climate scientist might actually come up with. And so I look at this as an opportunity to actually teach the public a little bit more about the type of maps that are created and the understanding that we can actually get from these different views of human scale and that space-based scale.
So some of the next steps we're working on is getting all of the unclassified photos posted up to a website, potentially called Zooniverse is one of them, or doing another platform where you can go on, and they have all sorts of projects on that website and classify all sorts of different photos. Right now there's a snapshot Serengeti project there where you can classify animals in Africa. They also have photos of the universe, and you can go classify different stars. So we're thinking of partnering with them and having some of these unclassified land cover photos posted, so somebody in there, sitting at their computer who didn't go take that observation can go look and classify the land cover in those photos and get a lot of those blank observations with a classification, and that will definitely help out the data. The other thing we're working on is working with Google Voyager. So Google Voyager is a brand new platform that Google put out. They're kind of beta testing it and doing some content, and they're kind of curating the content. So they approached Globe Observer folks a couple months ago about creating a Google Voyager story to kind of add on to their Lewis and Clark story that they already have with PBS. So look for that PBS one, it's pretty cool. So hopefully you'll see one from this summer. And then we kind of have a call for help. So the app it works pretty well, but there's some things that need to get updated since they built it a few years ago. So one of the features is the My Map function at the end is very kind of sparse. It's not super useful, and so that's one of the reasons why I wanted to make sure we came to NACIS this year, was to get some ideas on how to have a better interactive function that people could see their data that they collected, the land cover data that they collected, and also see other people's data and kind of understand why they're doing this and why it's important, kind of give that data back to them. So if you have any ideas on how to help us with that kind of interface at the end after they've collected some data, they can kind of see what they collected. Right now it's just pretty basic interface, but we would love some feedback on that. And that's all we have. Thank you.